Okay, welcome back. Hopefully you were, there's a little video from before. Hopefully you already watched questions 1 through 5, or maybe you just need help with the questions 6 through 10. So this is the video for questions 6 through 10 in the Unit 3 mid-unit assessment. So in number 6, it says rewrite the expression as a quotient and a remainder. So we're going to use the same strategy as we did on the last one. We're going to divide the expression by x minus 3. And we only are going to need 2 boxes here. And we may need this last box for the remainder. Okay, so what we're going to do is we're going to divide out x minus 3 from 2x squared minus 5x plus 8. So this first box has to be a 2x squared, and that's because we know that 2x squared is the result. So when we divide it, we're going to need to use a 2x to create that 2x squared. And when I have a 2x times negative 3, we're going to get negative 6x. Okay. Now we know that we need to have minus 5x's, and over here we have minus 6. So we've got to add 1x to this, and now you can see between these two boxes that's still adding up to the negative 5x. So that has to be true, and if that has to be true, then I'm going to have to multiply this by plus 1. So plus 1 times x does give me the plus 1x. However, now that I know that this must be a 1, I'm going to multiply by the 1 times the negative 3, and that creates negative 3. So that is an issue because we're supposed to have plus 8. So that means that negative 3 plus something is going to make an 8. So if we do the math there, we're going to add 3 to both sides, and we now know that 11 is what we needed to add there, 11. So if I add an 11 here, now the 11 and the minus 3, they both combine to make our plus 8. So the way that we're going to write this out is we would say that the quotient is 2x plus 1, and the remainder is 11 over what we divided by, which is x minus 3. So that is going to be our result. Okay, we had a quotient, which was right here, 2x plus 1, and then the remainder is right here as plus 11 over x minus 3. We also know that this is the slant asymptote. And like I said, my students will be covering that on Tuesday. So we'll be going over that on Tuesday. It is a small part of the quiz, but the majority of it has to do with graphing rational equations. Okay? So just a quick demo of how we would do that with synthetic division. I'd put a 3 in the shelf, and I would take this number 2, negative 5, and positive 8. 2, negative 5, positive 8. And then I perform the synthetic division. Bring down my coefficient of 2. 2 times 3 is 6. I add those, I get 1. 3 times 1 is 3. And there's our remainder of the 11. So there's our 2x plus 1 plus 11 over x minus 3. Okay, so that was another way to get that answer. It's definitely less conceptual, but it does get you to the answer quick. Okay. Anyone interested in learning that from my classes, you can come after school Tuesday or Thursday, and we can do that. Okay, that's some notes from my other class. Now we got number 7. It says to simplify this fully. So I start looking at each of these terms, and I need to start imagining that I'm going to factor them. Okay, so we know that when there's a division sign, we need to flip that second fraction and change it to a multiplication problem. So what we're going to do is we're going to just first change this into a multiplication problem. And you know what, as I write, I realize that we can take an x out of each of those terms. So I'm going to rewrite this as x times a quadratic. So we're going to have x times 3x squared and then plus 8. Okay, and then that is all going to be over, and I actually see an x and an x in there too, so I'll take out an x, and we're left with x minus 2. Now, the next piece we're going to multiply, and you're going to notice that this piece is now going to be in the denominator. So we're going to flip that fraction. We're going to multiply by the reciprocal. And then you're going to notice that this fraction is now upstairs in the numerator, 2x squared plus 8x. So we've changed the operation to multiplication by flipping that second fraction. And I'm just going to do like a little bit of cancel out right now because these two x's can go away. And my next goal on the next line is going to be, we're going to try and factor that quadratic. We can just write that x minus 2. We need to factor the blue and factor the green. So I'm going to start with a box method over here. And we know that the first term is a 3x squared. And we also know that plus 8 is our constant. So we know that this has to be x and 3x. That's the only way to make 3x squared. So I'm looking at the middle term, and I'm seeing a negative 10x. So if we're going to multiply two numbers, and we're going to get this box, and we're going to get this box all equal to negative 10x. Okay. So we first got to realize that if this 8 is positive, this has to be a minus and a minus, because negative times a negative is going to make a positive, and we need to either try for 8 times 1, or we could try for 4 times 2. We really have a couple options, but we want to try with a negative 2 and a negative 4, and if that ends up multiplying out to negative 10x, we're going to have a good factoring. So let's see, x times negative 2, that'd be negative 2x. And then 3x times negative 4 gives us negative 12x. So we got negative 14x, and we're supposed to get negative 10. So unfortunately, that's not going to do the factoring. So let's try another one. We know it has to be plus 8. We know it has to be 3x squared. Let's try and reverse the 2 and the 4. Let's see if that works. So x and 3x. And then let's try, instead of minus 2 up there, let's try minus 4. So that would be minus 4x. And then we would need a plus 2. Or no, sorry, minus 2. Yeah, minus 2 times 3x. That gives us negative 6x. So we were wrong on the first one, but once we switched those numbers, we ended up getting a negative 10x altogether. So that's a good lesson. Your box method may not come out right on the first try, and you have to keep trying. I noticed on quizzes and tests, some of you try one box method, it doesn't work out, but then you just fake it and you say, yeah, that worked, and then you continue on with the problem. You're going to head into a dead end because you won't be able to finish the problem correctly. So sorry for that little rant there. But now we know that this polynomial right here is actually x minus 2 times 3x minus 4. So I'm going to create another little space for the problem. And let's start to let's get rid of this factoring, because we now know the factors. Okay, so let's give this whole thing a shot. So I'm going to rewrite these factors right here, but I'm going to write them as x minus 2. So x minus 2 times 3x minus 4. And that's all going to be over x minus 2. And then this is multiplying And we're going to have to factor the green and the blue. So I'm going to start by factoring out a 2x from the green. And that leaves me with x plus 4. And then let's re-multiply that in our heads, or just out there. 2x times x would be 2x squared. That's good. And then 2x times plus 4, that's plus 8x, and that's good as well. So we can know that those are correct. And then we're going to factor 2x squared minus 32. Notice there is no x here, so I can't take out an x. All I can do is take out a 2. And we're going to be left with x squared minus 16. So you're probably noticing a little bit more can cancel out. And we can do that now. So the x minus 2 will go away, the x minus 2 will go away, the 2 can go away, and the 2 can go away. So I'm sort of canceling as I go here. And let's write a new equation. So notice this is gone, that's canceled out, this is canceled out. We're really just left with the 3x minus 4. And then I'm going to just use this multiplication sign to continue. We would have an x here, and then an x plus 4. And the denominator, the 2 has canceled out, and this right here is going to be written as x minus 4 and x plus 4. We're trying to think of two numbers that multiply to negative 16 and add up to 0. So 4 plus negative 4 does the job. All right, finally coming around the bend, x plus 4 is another common factor. Just looking for anything that's in common. And your final answer is going to be 3x minus 4 times x all over x minus 4. Okay, so I think that one went pretty smooth, but if you need to go back and see where things canceled, we had like 3 rounds of canceling here. We started by taking the x's away, then we took x minus 2's away, then we took 2's away, and then the x plus 4 common factor. So we tried to just save a little bit of room as we went, just so that we could have enough room to do the whole problem. All right, let's try number 8. Number 8 is very similar, so I'm going to factor in a similar way. Let's start by factoring the top here. So right there, that numerator, we're going to take out an 8x because I see 8x squared and I see 32. So I can take an 8 out of both of those numbers, and I can take an x out of both, and you're left with x plus 4 there on the top. Okay, so this 5x squared, we're going to take a 5 out because there's no x over here on the negative 20. So I'm just going to take a 5 out, and we are left with x squared minus 4. So the next term, we're going to make sure that we switch the sign to a multiplication instead of a division, but then we know that these are going to have to flip. So essentially, this green piece is now upstairs, 4x squared plus 3x minus 10. And then this blue one over here is going to be downstairs. And I'm going to take an x out of that because each term has one. Okay, so from here, we're going to want to start to factor. Now, I will admit, these factors right here, okay, this x squared minus 4, that's an easy one to factor. But when you look over here at 4x squared plus 3x minus 10 and 2x squared plus 5x minus 12, that is a gross factoring. And I can tell you that we will not be giving you something quite this hard on the level 2 quiz because that is a lot of factoring, and that's not one of our main focuses of this unit. But right now I'm going to continue factoring it because we're going to need a little bit of, we're going to need to see if there's any common factors to cancel out. So I'm going to give you a quick little hint on these types of problems because when you start to see stuff like x squared minus 4, and these factors are really, they're just bigger because the leading term is not 1. Chances are x minus 2 or x plus 2 or x plus 4 is going to be somewhere in the problem because stuff has to cancel out. Now that's just more of a math class tip, not really a mathematical tip. It's more of a math class idea. But you can kind of do that however you want. If you want to use the box method, I think that's definitely a viable way to factor this. So we have minus 10 and 4x squared. And all together we need to have plus 3x. So when I start to look at this, I'm trying to think whether or not we're going to need 2x and 2x, or maybe we're going to need 4x and 1x. But for now, I'll start with a 2x squared, and we're going to think of ways to make negative 10. So I'm going to try to do a plus 5 and a minus 2. Because that would make a negative 10. So let's see if that works. 2 times 5 is plus 10x, and 2x minus times negative 2 is going to be minus 4x. So together, we ended up getting plus 6x, and we're going to need plus 3. So that one did not work. So I think we should try 2x, 2x, so that's another way to make negative 10. Negative 10, negative 20x plus 2x, 4x squared. That does not seem to be working, actually. So this would be a 4x squared, but we're not getting the plus 3x that we need. So we just got 2 examples, and we didn't get really close to 3x. So in that case, I'm going to change the 2 and the 2 to a 4 and a 1. Let's see if that factoring can work out. So if you are going to get frustrated by watching me try and factor this a few more times, you might want to skip forward on the video, but we will get there. So I'm going to try 1 or 2 more times. So this is a 4x squared. We're going to use a 4x and a 1x. And this has to be a minus 10. So let's see what we can do. So I'm going to try a minus 2 and a plus 5. Let's try that one. So 4x times this would be negative 8x and a plus 5x. Okay, we are getting somewhere now, because if we look here, negative 8x and plus 5x, that's not positive but negative. So we're so close, we're going to just switch the signs. Negative 10, a 4x squared. This is going to be 1x plus 2, and this is going to be a minus 5 with a 4x. Let's try that one out. That's going to be minus 5x plus 4x times 2 is 8x, and yes, ding, 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 we did get plus 3x. So yeah, that was 4 different times we had to try and factor that, but we were successful. So let me actually rewrite this in. Okay, now these factors are coming from here. So x plus 2 and 4x minus 5. And then let's do a whole denominator now. We've got 5 times x minus 2, x plus 2. There is a blue x over here, and then we're going to have to factor this beast over here as well. We're going to have to use negative 12 and 2x squared. So we will get there in a second. Let's see. So we know it's going to be x and 2x, and it's got to be negative 12 over there. So -3 and a +4. Let's see if that does the trick. 2x times 4 is 8x, and x minus 3 minus 3x. There we go. We did get it, because that's plus 5x. 8x minus 3 is plus 5x. And that was a good one. Sometimes you get it on the first try, other times not. It's okay. I think it's actually good that you guys are seeing that, you know, a math teacher can still have to try it a few times to get it, right? In the process, hopefully you heard in my voice, I didn't get frustrated. I just tried to keep going and try new little changes. Okay, so enough philosophy. Here we go. The x's are going to cancel. The x plus 2's are going to cancel. The x plus 4's are going to cancel. And it looks like there's nothing else in common. So the final answer is going to be 8 times 4x minus 5 all over 5 times x minus 2 times 2x minus 3. Okay, so I will tell you that this question is too hard for the standard Algebra 2 class. This is going to be more of an honors level question, but it is it's actually a great review. Sorry, taking another sip of my afternoon coffee. All right, let's jump over to, did I jump too many? No, 8 to 9. Okay, so this is an application problem. You are going to see one of these on your quiz. And this one is saying that a plane is going to fly 350 miles at a planned speed of 500 miles per hour. So I think what the key to this one is you need to know that the plane, right, the plane is traveling at 500 miles per hour. So when it goes into this next part, it says the flight will have an average headwind of W miles per hour. So when a plane goes in that green arrow direction and there is a headwind, right, this is headed towards the plane. So what ends up happening is that the plane is going to be slower because the wind is pushing against the plane. So when the wind is pushing against the plane, it actually makes the plane travel slower, right? And so if you do all the math to this, if we had crazy winds of 500 miles per hour and the plane was going 500 miles per hour, all of a sudden these two, the wind and the plane, would be going in this opposite direction but the same speed. And weirdly enough, that would kind of make the plane just fall out of the air. Right? So you need to make sure that you're understanding this idea of a headwind, because the plane, right, the plane's head would be in front, and they call it a tailwind if there's wind at the back of the plane. So our whole idea here is that this scary 500 mile an hour wind is actually forming your asymptote. And we'd say that the asymptote is 500. And you can look algebraically back at the numerator. And you can see that if I set 500 minus W equal to 0, we get W equals 500. And so that is the asymptote, because at this spot, that is the wind speed where the plane can no longer fly. So I know this application is a little bit strange, but that's really what they're saying, is that if the wind is more strong, right, the wind is stronger, then our travel time is going to be much longer, okay? So it's important to pay attention to variables here, right? They say that the headwind is W and the time is T in hours of the flight. So if there's no wind, right, and there's very, very low wind, like right here, if the wind was only 100 mile an hour headwind, you can see right here that they expect the trip to take about 1 hour. But if, let's say, there was a 400 mile per hour headwind, then that means that they expect that the trip would take almost 4 hours. So I think what's really important here is that you understand down here, right? This is the wind, 100-mile-an-hour wind, 200-mile-an-hour wind, 300, 400, 500, 600. Those are all wind speeds. And over here is how long the flight takes. This is 2 hours or 10 hours. And so I think part of the tricky part about this application problem is that it's really hard for our brain to comprehend speeds of wind that are 300-400 miles an hour because we're never outside for that, right? We're up in a plane in the air experiencing that without really knowing it. So I want to be very careful to make sure that while this may sound easy to explain, this is not an easy idea to grasp. So if we need to go over this a little bit more this week, we definitely will. Okay, so just keep in mind that when you have 140 as the input, they're talking about 140, which is about right here. Okay, right there. So what we could do, okay, it says, what does T of 140 mean in this context? So keep in mind that it's 140 miles per hour wind. And we can plug that 140 into our equation right up top here. So T of W, we're going to say T of 140, it equals 350 divided by 500, take away the wind. So that speed, right, when we see 500 minus 140, it's really telling us that 500 miles per hour is going to actually be about 360 miles per hour. 350 divided by, if you do a calculator move there, it's going to be 360. And I'm just going to run and get a calculator to do that. Actually, I can ask I'll just get a calculator. So 350 divided by 360, and that would be 0.97, and that was T, so that was travel time, and we would expect 0.97 hours. Now, I believe that we would probably give you most of the credit for a 1, because if you go 140 on the x-axis, it hits roughly 1. So what does this mean? Well, if I need to talk about in context what this means, it's if the plane faces 140 mile an hour headwind, we expect the flight to take, we can say approximately 1 hour, or you could give me the exact one that you got if you did it algebraically and you plugged in 140. Okay, so that's part A, and I want to warn you, that's really only worth 2 points on your quiz. So I don't want the details to make you think that because it's a little bit difficult, it's going to be half of the points on the quiz, right? This is actually a harder concept, so we're not gonna be making that a lot of points. Okay, so just wanted to talk about letter B. It says, at what value of W does the graph have a vertical asymptote? So we actually already calculated that up here. We said that it was going to be x equals 500. So we're going to say x equals 500 is a vertical asymptote. We're going to say because if the headwind was 500 miles per hour, that looked like a 5, sorry.